We're looking at dihybrid crosses. What is a dihybrid cross? You were looking at two traits or two factors. So I'm using Gregor Mendel's term here for traits or alleles slash genes. So two factor slash trait crosses. So Gregor Mendel, he was looking at either or traits, and he wondered, hey, does one trait affect the gene for another trait? Like, does the pod shape gene affect whether or not the outcome of the seed color would be the same? So this is called independent assortment. Basically what happens is that the alleles, they line up kind of randomly and that they do not affect each other. So let's dive into it. So here's his experiment. He started with true breeding plants. In this case, let's focus on true breeding round and yellow peas. So the genotype here is big R, big Y, big Y. So they were round and yellow. They were showing dominance for both traits. And he crossed them with true breeding recessive traits. Wrinkled green. So wrinkled little r, green little y. So you cross these two together. In the first generation, 100% round yellow peas. These are the hybrids. Then he allowed the F1 plants to self-pollinate, created an F2, and these were the results of the F2. So I'm going to get my calculator. Let's do some math here. So 315 out of 556. I get roughly 0.57 or 57%. 32 divided by 556 times 100, get roughly 6%. And then 209 divided by 556, roughly 38%.
That's like 6 flat.
59.
Okay, so the conclusion is that the alleles, they segregate independently, they are not dependent on other genes, and they do not influence each other. So we're actually, I'm going to just write these numbers off to the side here, because we're actually going to do a dihybrid cross, and then we can go back and compare his data with what's going on. And then combo. Okay. So this is what a dihybrid cross looks like. And I'm going to have to sit so I can write. And the first step is you're going to start with the parents. So here they give me the parents. This is parent number 1, parent number 2. And before you start writing letters, just stop. You have to do something special. Okay, you have to distribute. Okay? So how do you distribute? You start with the first letter, and it's going to be paired up with this letter and this letter. So these are two gametes. So in this first box, I'm going to write big R, big Y. And then the next box, I'm going to go big R, little y. Okay, now I got to take the second set and distribute. This gives me all the possible allele combinations or gamete combinations. So it's going to be little r, big Y. So I'm going to write little r, big Y. And then the last box is going to be little r, little y. Okay, so now we got to distribute parent number 2 using the same method. So you take your first letter here and go ahead and distribute it to figure out your allele combinations. So big R, big Y, big R, little y. Now I'm going to take the second set and distribute it. Okay. Little r, big Y, little r, little y. Okay, any questions about that? So that's the first thing you got to do on the dihybrid. Okay. Otherwise, if this was just a simple Punnett square, go ahead and you'd separate the alleles. Okay, so we have figured out the gametes. Now we've got them lined up, and now we get to do the fun part of filling this in. Okay, so this is going to be super, super tedious. So this first square, I have big R, big R. Does everyone see how I got the 2 big R's? And it's going to be big Y, big Y. Right? Okay, so let's go on to this box right here. Big R, big R. Big Y, little y. All right, third box across. Big R, little r. And then 2 big Y's, it looks like. Final square here, big R, little r. Big Y, little y. How are we feeling? Okay, let's go on to the second row. So, big R from the top, big R from the side. So I got 2 big R's again. And then it looks like a big Y, little y. Big R, 2 little y's. Big R, little r. Big Y, little y. Do you guys want me to shut up and you guys can just fill it in? No? Yeah? Okay, I'll shut up.